Hey, welcome everybody. This is N2QOJ Joe to another episode of Let's Analyze Something with Simple Tools, free tools. And that something is going to be hopefully ham radio related. Alrighty. So just a little bit of advertisement who I am. I'm involved with the Queen Creek Amateur Radio Club and the Queen Creek Emergency Communications Group. And there's my information on the screen and an old picture in an old office. Alrighty, let's get moving on. What are we going to do here? Let's look at the tools we're going to use. We're going to use an open source cross-platform audio software application called Audacity. Some of you may know it. It's a wonderful, excellent tool for analysis of audio files and editing and all kinds of good stuff. And the version I'm using is just a couple back, and it's going to be very similar to what you're seeing on the screen. Another tool we should be using later. You've heard of FL-Digi. FL-Digi is a computer program developed for the amateur radio community that helps decode and encode digital modes. And enough of that right now. We'll show you how we use it. We're just going to use it as a simple tool to help us in what we're going to analyze already. So let's put that away. And we're going to fire up Audacity. When we turn on Audacity, we have a blank slate here to work with. We're going to load up an audio file. As you may know, the Queen Creek repeater is recorded 24/7, and I have access. It's recorded and it's also streamed in near real time, and I have access to all the recordings. So I thought we would analyze some information that comes across the repeater on a regular basis, which you've all heard probably if you've listened to the repeater or spent any time on the repeater. But we're going to go look at it. We're going to visually analyze what comes across the repeater as some information. So I made a recording, edited a little bit so we just have a snippet. I'm going to load that up now. I'm going to open up an audio project. And as you can see, there it is. I'm sure you've all seen audio captured files on TV and police shows and things like that, if you haven't ever experimented yourself. And you can see voice patterns and things like that. And this is similar. This is a snippet of a sound file. We're going to let you hear what it sounds like now. No, I don't hear anything. Why is that? Okay, let's see what we've got here. We'll play it one more time. Okay, by now you've probably guessed it. That's the repeater ID. And knowing that, you probably know that the repeater is identifying in Morse code its call letters or call sign. If you look at the actual visualization of the sound up here, have you noticed it yet? What we were listening to was Morse code. If we stretch this out a little bit, do you see it now? Da, dit, D, E, da, dit, N, da, dit, 7, da, dit, another D, dit, da, J, da, dit, Z, D, E, or as we say in French, de. But it's also how ham radio operators say by or of, DE. and the call sign, N7DJZ. There you go, a visual representation. We'll play it again. Okay, so if you hear it, if you're listening closely, you'll hear the actual call sign. You hear a hum. So there's a lot of interesting things going on here. So we've got intelligent information. We see the visual representation of the Morse code. And if you look, there's a little bit more deeper information here. Let's zoom in a little bit. We'll just go and take the magnifier. And let's go zoom in on that D, da, dit, dit. Okay, let's zoom in. And that's a dit, I believe. And there's the dash. You see what I see? It's made up of sound. You have an overall wave here. You see the period from here to here, and then you have one inside. There's a couple. So there's lots of different things going on here. Let's zoom in a little bit more. And what do you think we'll figure out here? We're probably going to figure out the tone that we've been listening to it. You see the selection I just made? Go down here to the bottom of the screen and you'll see the selection start right there. If I go to the top of the waveform here and there, that's one period, what we call T. Capital T is a period. We also know that T equals 1 divided by frequency. And frequency equals 1 over T. So armed with that information, let's take a look here what we've got. So we look at the selection start and it's a selection end. So it's 2.273 seconds, 0.274 seconds. So that's a difference of 1 millisecond. So what we're going to do is find the frequency, which should be equal to 1 divided by 0.001 seconds. Let's make it easy. 1 divided by 0.001, 1,000. 1,000 hertz. There you go. Our tone is 1,000 hertz. That's the Morse code tone, and that makes kind of good sense. So let's get rid of that. How can we corroborate that? Well, why don't we play the whole thing again, the whole selection, but this time we'll use a tool such as FL Digi in CW mode, because it can also decode CW, and it's decoding my interference. This is acoustically coupled. So now, why did it do SE and 7DJZ instead of DE? Look over here. See, I started playing this not in the beginning of the clip, but right in the middle of the dash. So it saw it as 3 dits. 1, 2, 1, 2, and 3. Let's move that here, where it's supposed to be. Clear it. And again. And there you go. FL Digi has successfully decoded the CW to DE and 7DJZ. And if you look here at the bottom, if you're familiar with FL Digi or similar waterfall programs, you'll see that this is the frequency that it's decoding. And look at that, 1000 hertz, or pretty close to it anyway. So there you go. We've pretty much identified that. All right, remember we said there's more information here than just the Morse code. We could see that there's additional frequencies in here. So let's expand this a bit. We've pretty much decoded the tone. And what's in between the dots and the dits? That's the hum. What you see here is the hum that you hear. So let's go look at that hum and see what frequency is involved there. So we'll just move the selector around a little bit. And how do we do that? Again, look at the bottom here. We're going to select the top of the waveform and the top of the next waveform. That should be our period. Alrighty. Now, the interesting thing here, can you guess what it's going to be? What is a hum usually? Usually an AC hum of some type. The repeater may be transmitting it. It may have been picked up by my scanner that does the recording. We don't know, but there's something there because it's a repeating waveform. So let's see what that is. There you go, 3.562 seconds minus 3.5, or let's do 3.579 minus 3.5. So let's see what that becomes. So 3.579 seconds minus 3.562. So it's obviously going to be around 7 milliseconds. Oh, I'm sorry, 12 milliseconds. There you go. Okay, so remember our formula? So we're going to put in 0, 1, 2, 12 milliseconds. And what's that going to equal? Oh, that didn't make sense because we didn't do it right. Okay, 1 divided by 0.012. 83.3 hertz. That's interesting. I would have expected 60 hertz or something around there, but it's obviously an AC hum. I don't think it's the PL. The PL is closer to 100, but maybe if we zoom in a little bit more, and let's see if we can get a little bit better. No, it's still the same, 0.012. So anyway, what we've just determined here is that we got an 83.3 hertz tone in there, and that's basically an audio hum. Do we have anything else going on? Well, you could see there's the tone of 1000, but here's another waveform. You can see it? There's another waveform right there. So let's look at that one from here to the top of here. So it is, if we look at the difference and just do it in our head, it's about 17 milliseconds. 1.948 minus 1.931, so 17 milliseconds. Let's see what that is. 1 divided by that will give us the frequency. Oh, there's our 60 hertz. There you go. So you know what? So our 60 hertz hum is riding along here, and what we saw here in between the dits and dahs is the PL tone. It's coming across as 83 hertz, but again, with all the different errors introduced by the streaming recording and interpreting here, it's plausible that it's a little bit off. So we've got intelligent content, the Morse code of the DE and 7DJZ. Okay, we've got that. Then we've got the actual 1 kilohertz tone that comprises the Morse code tone. Then we have, when we zoomed in on that, we saw the 60 hertz hum that it was riding along. And then when we look here, we see what should be the PL tone. So there you have it. Quite a bit of information in that just little, here's 4.5 second snippet. So that's what you can do with something like Audacity. Great tool. There's a lot more too, but and we found another use for FL Digi. Let's see. We can put that back. And let's. And there you go. Very good. So, excuse my little simple graphics here, but we'll close this all up. And there you have it. I hope that's interesting and you'll find some experimentation with Audacity. It's a great program. You can use Audacity to take vocals out of sound cards and, again, edit things that you may be recording off the air. Very simple to go in and just grab something, delete it, and so forth. Go bring it back. And you can also put in effects. As you can see here, there's a lot of stuff you can do with Audacity. It's a wonderful, powerful tool. That's it for me, and I hope you enjoy this. This is a lot longer than I expected it to be, but it's always fun. 7-3 for now, N2QOJ. Take care.